Hello, everybody, and welcome back to this video about OnSSET and how to um, map or to visualize the results that we get after running the model and how to run the model itself. Okay, so some of those tasks were mentioned already during the seminars, and you have already some videos that mention how to collect the data to create the input file. So we're gonna complete the workflow by summarizing a little bit a way to display the results and share the results with others eventually. So if you remember here when we talk about onset in the seminars, at some point we talk about input data and we create the population data. That is the basic layer that we need to define the mapping unit of onset. And then we list some of the data sources that we need, especially GIS data that we need to prepare the model. Okay, some of these data are mentioned here in the onset documentation, and we also try to include some of them in the previous discussion. So we are talking about location of roads, infrastructure, um, network, grid, nighttime lights, and information about irradiation, wind velocity, all the layers that we need to calculate the optimal solution to minimize the cost to reach the target that is set for our area of interest, for our country, according to the models. Okay, so you see all this list of layers, including wind, we say hydropower, travel time to the closest city, elevation map, land cover, and some optional layers like the custom demand. And these layers are also listed here in the documentation that we share with you, and some examples. Some links are included here in the installation guide for OnSSET in our platform. So you can see here some suggestions about where you should or where you could find the data if these data are not available for your area of interest, for your country. So it's important, of course, that you use accurate data set and updated if you want to get accurate results. But we already mentioned also the fact that in terms of spatial resolution, you could have a very high consumption of computer resources if you want to work with data set with a very high spatial resolution. Okay, so it's a little bit of compromising, especially in creating and defining the population data. Okay, so we talk about all these decision that you should take before running the model. But we also mentioned that you have some other source of data set that you can use. For example, this one, right? World Bank Energy Data Info. You can find already data that are available for OnSSET, like the one of coming from the global identification platform. Okay. So once you download and you clip all the dataset that you need to your area of extent, then you can run the model, and you can run the model with a plugin that is available for Quantum GIS, or you can create your own workflow in a GIS. Usually, I work with ArcGIS Pro or in Python directly. But you can use according to your according to your preference, you can use the plugin for QuantoGIS. You can create your own workflow in ArcGIS Pro or running directly the model in Python. And we show, in the installation guide here how you can how you should set up your environment before doing that. Okay, so at some point, if you follow all the instruction in the installation guide, you have the video as well. You will be able to connect your Python model or OnSSET Python model to your plugin, or you can run the model directly in Python. Okay, so here we go through the QuantoGIS platform, because we have already the plugin is already developed and um, uh, already available to run the model directly. So here I have an example of Ghana. So you have the boundary, you have all the layers that you need, like the wind, the travel time, substation, irradiation, the slope, the road infrastructure, land cover, um, the hydropower, existing grid, the population, and night lights, and the elevation. Okay, so once you were able to collect all this data set that you need to run OnSSET, you can use the plugin. So here is the plugin. Okay, I will explain how to install. It's very simple how to install the plugin in the installation phase. So you select a workspace that is a folder. So you can select your folder here. I can use it one in training. Let's see, I use this Ghana training, and I create a new folder here. Workspace doesn't exist. I select this folder. Name of the study area. You can use the name of your country. You select CRS or coordinate reference system. I'm using here the Ghana National Grid, or you can use the WGS84, the one you prefer. Then you have the population data. You remember that you have you created in the previous step polygons describing the population distribution within your area of interest, and you need to have a polygon vector file with the total population living within each polygon. This is the minimum mapping unit for OnSSET, because OnSSET is going to calculate which is the least expensive technology to reach the electrification target for each polygon. Okay. Then you define your boundaries. Okay, it's another vector file. Is the polygon defining the boundary of your country, and then you have the GHI, is a raster file. Then you have the wind speed, raster file, travel hours to the closest city, is a raster file. The elevation is a raster file as well. Elevation, custom demand. If you have it, you can include it. The land cover is another raster file with basically here for the land cover, OnSSET use distinction between urbanized area and not urbanized area. This is the most important category that you should include in this file, and the specification of the land cover are you can find them here. here in this web page, in the data acquisition page of OnSSET on the website. So this is the format that is expected for by OnSSET. So if you use the raster dataset, you should remember to classify the or to reclassify your land use classes according to this table, or if you want, you can also define the parameter in the code, in the Python code itself. Okay. Here, this table is created according to the MODIS classification, but you can use other sources. Then you have other vector file, so the high voltage and medium voltage grids, and I don't have it here, and the rods, vector file, substation, is a point vector file, transformer, if you have them, point vector file, hydropower, point vector file. If you have hydropower, you should select if you're using the, which is the unit of measure. In this case, I have megawatt, and I select megawatt here, okay? When you select all these layers, you can click run and wait. And waiting means waiting a lot. So we are talking with a country like Ghana with this special resolution, with a very good performance, where you can wait something like more than 7 hours, 8 hours, 12 hours sometimes of running time. Because when you create this, when you run this model, what the plugin is going to do is creating a list of output for all the different scenarios, okay? At the moment, if you use the plugin and if you're not modifying the code, all the scenarios for all the parameters are created. So we are talking about 96 file that for Benin are, let me see if I have the output for Ghana or for Benin. Yeah, let's see. The one for Benin that is very small is only for only is for 31 gigabyte of CSV file. Okay, so when you talk about a country like Ghana, in which you have maybe 4 times, 10 times the polygons of another small country, you have also much longer waiting time for running the model and creating this CSV file. Okay, so the only thing you can do is really just wait that the program finish if you are going through if you decide to use the plugin. Okay, the only way to avoid or to work only with the scenario that you want to use is to use a web interface like the global electrification platform that I can show you. Python, sorry. I can show you here, or to modify the code. Okay, in the global electrification platform, if you use the web interface and you select, let's start with Benin. You can see here that you can select the characteristic of the scenario and then apply, and then you can download or export the results. Okay, but if you run OnSSET by using the interface, by using the code, you need to wait because it's gonna create all the output scenario. Okay, so when you run it, okay, and you wait all these hours, just a reminder that